Oh, thank you for joining me. I'm going to be looking at question 9. Question 9 says the diagram shows a cylinder container with end radius r and length y centimeter. If the total circumference of the circular end, so let's put a cylinder, and let's put and we've got a radius r and we've got a height of y centimeters. And they're saying the total of the circumference and the length of the cylinder plus the length is to be 120 centimeters. So the circumference is 2 pi r and the length is y. And so that's going to equal 120. It's good to know one of the variables. I will take y alone, simply because we want another formula. Find the values for r and y that maximize the capacity. So the capacity is generally the same as the volume, although it's good to know the capacity is measured in, say, milliliters and volume is measured in cubic centimeters. However, the volume and capacity is 1:1, so 1 milliliter is 1 centimeter. So let's have a look at the volume, and the volume is pi r squared, area of base, times height, which is the length. And we want to optimize that, so we get dv dx or dv dr of that equation. The thing is, we want only one variable, and so here we substitute out the y and we put in 120 minus 2 pi r, and that will give us the formula pi r squared times 120 minus 2 pi r. So that was originally y, and we've replaced y, so now there's only one variable, it's r, and so we can get dv dr. Let's just expand this to give 120 pi r squared minus 2 pi squared r cubed. Alright, so dv dr is 120 times 2, so 240 pi and r to the power of 1 minus 3 times 2 is 6 pi squared r pi squared r squared. And we let that equal to 0, and we solve this. So to optimize, we find where the derivative is 0, and I'm going to factorize, say, 6 pi r. That leaves 40 minus pi r. Therefore, r could be 0. No, we want a radius to have some length. And 4 minus pi r equals 0. Therefore, 40 equals pi r. 40 over pi is the radius that will give us our optimized capacity, but we want to test that in the second derivative just to make sure it's a maximum, which means it will be a concave down curve. So let's test in the second derivative, and that would be 240 pi minus 12, because 6 times 2 is 12, pi squared r. By putting 12 times pi squared times 40 over pi, so one of those pi's cancel, and we've got 480 pi, so negative 240 pi, which is negative, so it's concave down, therefore it's a maximum at r equals 40 over pi centimeters. Do we want the capacity? Just the value of r, and also the value of y. So if r is 40 over pi, therefore y is 120 minus 2 pi r substitute 2 pi, substitute 40 over pi, and that will cancel that. So 120 minus 80 is 40 centimeters. So therefore, there we have our length and our width. 2 pi r. Then that is our final result. I hope this has helped. Until next time, stay happy.